So, what are you guys thinking of factoring? Are you enjoying it? I think it's pretty fun, and it seemed like that one that we did right before we left on that Monday a couple of weeks ago, that you guys did okay with it and thought that was kind of different but not bad. I'm telling you, the more you do these things, the more addicting they get, and we're going to jump right in with them. Now, yesterday we did something that slightly varies with what it is that we're going to be doing today. Yesterday we factored numbers in the form, trinomials that is, 3 terms, and we did those without that a in front of it. We just did x squared plus bx plus c when b is understood to be some number and c is understood to be typically some number. And even though we technically had a 1 in front of those x squareds, at the same time we didn't have numbers as large represented by the a in front that we're going to have today. These aren't that much more difficult, it's just they have one more step to them than the ones that we did yesterday. But it's the same principles, okay? Now yesterday all we did was consider this number, and then what factors of 2? Well, it's largely the same thing, except what we're going to do is multiply this last number with the first number that is found out front. What is 2 times 6? Or I'm sorry, I always do that, don't I? What is 2 times 3, doy? 2 times 3 is 6, correct? Well, I multiply that last number times the number in the front to figure out what factor am I trying to find of that number. So 2 times 3 is 6, and now I ask myself not what are 2 factors of 2, but what are 2 factors of these 2 numbers multiplied together, which are 2 times 3, 6, okay? What are 2 factors of 6 that when added together, it's still the same thing as what we did before, as far as they need to total 7. 2 factors of 6, because these have been multiplied together, 2 factors of 6 that when added together equal 7. That's a pretty easy one, isn't it? And here's why. It's a positive 6, and when added together equals a positive 7. Well, how about the highest and lowest factors? 6 and 1. 6 plus 1 equals 7, so bingo, there you have it. Now, yesterday, what we would do when we didn't have a number other than an understood 1 in front of the x squared, we would just put 2 parentheses out, write in x at the front of them, and then some positive or negative number as we found up here, and then we were done. We have one more step in these, since there's a bigger number than 1 in the front. Here's the way you do it, guys. You're going to use that 6 and that 1 in the middle, okay, just like we did before. But here's what we're going to do. We're going to rewrite the first term, 3x squared. Now what we're going to do is write one of these with an x, okay? 3x squared, we're going to write one of these with an x, because we need 6x plus 1x to equal 7x, if that adds up. No pun intended. Okay, so we're going to write plus 6x, and then we're going to use the other one also in the middle, plus x, or 1x. Does it help for right now if I just write in that 1 with an x so it doesn't get as confusing, hopefully? Stay with me. As always, the first one's going to be a little bit that way, but the rockiness will get out as we move on. So 3x squared, I just bring that down. I do a plus 6x from one of these numbers, a plus 1x from the other of the 2 factors that when added together equal, see, 6x plus 1x, they equal 7x. That's what that means. And then, like I did with the first number, I just pull down my last number. And so what I have is 3x squared plus 6x plus 1x plus 2. Now what I'm going to do, guys, is I'm going to make my parentheses, and I'm just going to bring these numbers, or I should say terms, because several of them have variables attached to. I'm just going to bring these two terms down, these two terms down in parentheses. And so I'm going to bring down in parentheses 3x squared plus 6x, close that parentheses. Then I'm going to say plus my 1x, okay, and we're not simplified yet, so we can write it that way. If it makes it less confusing, that's okay. And then bring down your last term, plus 2, also in parentheses. Okay? Now, here's what I'm going to do. I'm going to pull out the greatest common factor from this parentheses, and I'm going to pull out a greatest common factor from this parentheses. From the first one, what's the most that I have in common between 3x squared plus 6x? The most I have in common in the numbers is a 3, and the most I have in common with the x's is x to the first power, because each of them has at least a 3 in number, and each of them has at least an x in variable. And so I'm going to pull out a 3x, and I'm going to factor that. I'm going to divide 3x squared by 3x. Well, what's 3 divided by 3? That's 1, and since it has a variable, I'm not going to write 1 because I'm getting closer to my simplified answer. 3 divided by 3 is 1. X squared divided by x, you subtract the variables, remember when you divide, is simply x. So 3x squared divided by 3x is x. Now, I have to divide 6x by 3x. First of all, what's 6 divided by 3? That's a positive 2. And what's x divided by x? Technically it's not 0, it's x to the 0 power, which is 1, but because that is just redundant to write, we're not going to do that. And so 6x divided by 3x is positive 2. Does that make sense? I'm going to do the same thing now with the second parenthesis. And what I'm going to do with this is, what does 1x and 2 have in common? You might say, well, nothing. The x's aren't in common. There's only a 1 there. Well, wait a minute. Well, there is a 1. I know it doesn't sound significant, but it is for your answer. They do have a 1 in common, so I'm going to factor out, meaning divide both terms by 1. Even though that's all that they do have in common, I have to pull something out that they have in common, and a positive 1 is that. And so I'm going to divide both terms by a positive 1. What is 1x divided by 1? Well, that's just x. And what is 2 divided by 1? That is a positive 2. Guys, look at something of what I have here right now. What I have is the same thing in these two parentheses, and that's going to be an evidence to me that I have done things correctly. And you remember how you write your answer in factored form when you have what is in parentheses identical, okay, twice, and then you have something different on the outside. This is the way I write that answer. I use one of, but only one of what's found in that parentheses, x plus 2, and then I put in the other parentheses, and this time I don't put an addition sign, but I just put what's found outside of those parentheses, but inside the parentheses, because that's a shortcut. When you see it in this form and added together with the distributive property at work, it's the same thing as writing these two, but dropping one of those as being multiplied times one another. And let me show you. We're not going to go through and check every one because it'll get tedious. These are a little bit more time consuming. I do want to show you once, however. Let's FOIL this out. What is x times 3x? That is 3x squared. What is x times 1? Plus x. What is 2 times 3x? Plus 6x. And lastly, what is 2 times 1? Positive 2. Okay, let's simplify. Bring down your 3x squared. Combine your x's. What is an x plus a 6x? That is plus 7x. Bring down your positive positive 2. 3x squared plus 7x plus 2. What do you think? Does that look familiar? Bingo. We did it the right way. I anticipate that you're probably just a little bit confused right now. Then some may be saying, a little bit? Andolin, are you saying a little bit confused? I can see you saying that. And you might not be. You may be killing it. That's great if you are. But don't worry about it, guys, because that's the first one of these we've ever done. And we have a whole glorious chapter's worth of these to do. But really, it gets much easier. So let's do a little bit more practice. Let's keep moving and not draw this out too much. Now on number 2, remember, if I have a number greater than 1 in front of my first term, my x squared, then I don't just consider, well, what are 2 factors of 24? I can't do that. I have to multiply that times the number that is found in front of my first term. So what is 24 times 2? 24 times 2 is positive 48. So now I need to ask myself, what are 2 factors of positive 48 that when you add them together give you this number that's found in the middle, negative 19? Well, these 2 factors aren't going to cut it. That's not going to work at all. That's going to be 26, okay, and when you add those together, so that's not going to work. Obviously, 48 and 1 has to be a positive 48. You add those together, you have 49. You're not even close to negative 19. That big of a negative number tells you something. If it's a positive number, and when they are added together, it's that large of a negative number, what that's telling you is it's going to have to be 2 negative numbers multiplied together to equal this positive 48. And so let's start thinking about it in those terms. What are 2 factors of 48 that when you combine them get you to 19, even though technically it's going to be a negative 19? Okay, what are some other factors? 48. How about 6 and 8 are common ones in the multiplication table, but 6 plus 8 is 14. And that's not 19, so that's not going to work. What do we have then? Let's move on. We could do 12 and 4. Hey, how about 12 and 4? But 12 plus 4, even though that would 12 times 4 would get you to 48, 12 plus 4 only gets you to 16. It seems like we're getting closer though. I thought of something. How about this one? We don't normally use this because really 16 is off the multiplication chart, the common one. But guys, 16 and 3. What's 16 times 3? 16 times 3 is 48. Well, if I have a negative 16 and I add to that a negative 3, which is the same thing as just saying minus 3 because the negative overrides the positive. What is 16 minus 3? It is. Negative 19. That's what I need, isn't it? That's beautiful. That's where I'll start. But when you multiply the 2 negatives together, it gives you a positive number, and positive 48 for that matter. Okay, so let's plug in these 2 factors of positive 48, negative 16, and negative 3 that we have identified. Remember, in this way, when we have a number greater than 1 in front of that x squared, or whatever the variable is squared, what we're going to have to do is bring down that first whole term, 2x squared. We're going to attach the middle variable, or can be, as we'll see in a minute, variables, to each one of these factors. Okay, and we can write it either way. Let's do this one, negative 16, and attach that variable x. But don't forget about this one. There's a 4th term, minus 3x. We use both of them in the middle. And then we bring down our 4th term, plus 24. Okay. Now what we're going to do is we are going to rewrite these binomials in a parentheses, these binomials in a second parentheses. And so what I'm going to have is 2x squared minus 16x in my first parentheses. Okay? And we're going to combine to that. Don't worry about that plus sign that we're inventing because the negative is going to override it anyway. It doesn't matter. It's just technically this is the correct way of writing it. When I was in your guys' spot in school, I didn't go through the technicality. I left the plus sign off. Technically it's incorrect, but it's not going to throw you off in the end if you know what you're doing. Then I just bring these two numbers down into the second parentheses, negative 3x plus 24. Okay, I ask myself, this first set of binomials, what do they have in common? What's the greatest common factor? In numbers, they have in common, both of them can be divided by a 2. And so I'm going to put that 2 outside of a parentheses. What about the variable, x squared and x? Well, they both have at least a single x, and so I'm going to use 2x as my greatest common factor. I'm going to divide 2x into both of those terms. 2 divided by 2 is 1, and I'm not going to write that because it's redundant. X squared divided by x is just a single x, 1x. All right, what is negative 16, excuse me. Negative 16 divided by 2, that's negative 8. What is x divided by x? It's x to the 0 power, which anything to the 0 power is 1, but we don't need to write it because it's not going to change that number. It's redundant. So I factored out a 2x out of that first parentheses, which when I divided all that, and that's what it means to do, I end up with x minus 8. Now for my second one, what is it that I have in common with negative 3x and 24? I have a 3 in common with both. And here's a helpful hint. If you see a negative at the front, don't just do a 3 in this case. Do a negative 3, take it out of it. And it's just one of those things. It's the operation of how it works. So just do it that way. Make sure to take out the negative if the first term in a parentheses is negative. Okay, so what we have is I'm going to pull out a negative 3 because that will go into each one. They don't have a variable in common, but they do a number. So I'm going to put on the outside here a negative 3, okay? And when I divide in my parentheses now, negative 3x by 3, I'm going to be left only with what? Negative 3 divided by negative 3 is 1. 2 negatives make a positive. I don't write that though. I'm just going to write x. And what's 24 divided by negative 3? That is a negative 8. Ah, look at what I have. That's when I know there is a work of art on my hands, if I come up with the same thing in these two parentheses. But now, guys, how is it that I write this out as factors of one another? I use not both, but only one of what's found. This is a simplified way. One of what's found in the parentheses, which is x minus 8, and I use what's found on the outside of the parentheses, but put them inside of the second parentheses. And I drop the addition or subtraction sign because this is the shortcut of expressing the same thing. And I just write on the inside what's on the outside of my parentheses. 2x, and instead of a plus minus 3, there's one of those that's unnecessary. The negative overrides the positive, so it's just minus 3. And that is number 2 factored. And I could FOIL that out. We don't have time. I could FOIL that out and I would come up exactly with what I started. Okay, let's try number 3. My problem is 3x squared minus 20 minus 7x. Whoa, I said an x is at the end. Guys, be very careful about this sort of thing. They are so mean that they're trying to throw you off. The first thing you have to do is rewrite this problem in standard form so that you have an x squared, an x, and then the standalone constant number at the end. So let's rewrite it and not let them crash our exciting, fun Algebra 1 Wednesday party, right? So we have 3x squared, that's okay, but we need to move that x number, or term I should say, to the middle. 3x squared minus 7x, and then we put what was middle term where it should be in standard form at the end, minus 20. You'll get a totally different answer if it's not in standard form when we try to use these helpful formulas. Okay, so here's what we do have. at the end of negative 20, but remember, when I have a number greater than 1 in front of my first term when in standard form x squared, I have to multiply that negative 20 by the coefficient or the number in front of the squared variable. And so negative 20 times 3 is what number? That is, and if it helps me to write it, I can over here, just to the side where I know what I'm doing. Negative 60 is negative 20 times 3. Okay, so what are two factors that when added together are going to give me this middle number, which is negative 7? Two factors of negative 60. First of all, if you have a negative number when you multiply two numbers together, you know that one of them must be positive and the other one must be what? Negative. Otherwise, it would be impossible to end up with a negative number. And so you're going to have one positive number, you're going to have one negative number, and when added together, have to give you negative 7. You also know this, because that's a negative number in the middle, the factor that is a negative has to be the larger of the two. Otherwise, it would be a positive instead of a negative. And so there are going to be two factors, okay, of negative 60 that when added together are going to give us negative 7. What might those be? Well, let's ask ourselves. We could consider numbers like 6 and 10. Okay, but if you had negative 10 and a positive 6, and you combine them, that's just going to get you to a negative 4. And so that isn't going to be large enough. You're going to have a different one than that. So what could we do? You could do 15 times 4, okay? But 15, or negative 15 plus a positive 4, that's not going to work, right? Because you're going to be at negative 11, so that's too large. Let me think. Oh, okay. How about a multiple of 5? Okay, that's interesting. How about a positive 5? Okay. What would the other one be? What is 60 divided by 5? That's 12. But remember, the larger number has to be a negative. What's 5 minus 12? 5 minus 12 is negative 7. Bingo. We just found it. And so here's what we're going to do. In rewriting, you bring down, in this style, okay, you bring down your first term, 3x squared, and we're going to use each one of these. How about we bring over, you can do it either way, but I like doing ones where you can pull a factor out of each one. I think it's more fun to do it that way. So let's bring over the minus 12. Don't forget, the two middle terms both need an x with them. And then the other one's going to be a positive 5. It needs an x also. And then you just bring down what was the rewritten correctly in standard form third term, which is minus 20. All right? And now what we're going to do, and here's really an easier way of doing this, put parentheses but leave that positive out so it shows they're being added together. And just throw some parentheses over what you've already written. I like to do it that way personally. All right, what is common in 3x squared and negative 12x? We need to factor something out of it. Number-wise, 3 and 12. What's in common? Greatest. The number 3. Okay? What is in common in variables? Anything? X squared and an x. Well, the greatest commonality is an x. And now I just divide that 3x for what is inside of my parentheses to each one of those monomials. 3x squared divided by 3x. And we've done this type of thing enough, and right up here, we know that's going to be an x. Okay? Negative 12x divided by 3x. Or if you want, just put your sign and just say 12x divided by 3x. X's are going to essentially cancel out. It'll end up being 1, insignificant. 12 divided by 3, of course, is 4. How about right over here? What do we have in common between 5x and negative 20? Not a variable, but a number, yes. 5 goes into 5, and 5 also goes evenly into negative 20. So I'm going to pull out a 5, and what is 5x divided by 5? That's just going to leave the variable x. What is negative 20 divided by 5? It is a negative 4. Look at what I have, guys. Muy excelente, Miss Nicole would say. That's exactly after what we are chasing. We want both of those to be the same, but we're only going to use, when we write in simplified final factored form, one of those two. And then for the other parentheses that will be multiplied to it, that could be FOILed if we wanted to check it, is going to be these two numbers that are found outside of the parentheses. 3x plus 5. Okay. Now, let's do number 4. I know those took a while. I'll try to move a little quicker on these just for time's sake. And then if you need to, you can look back at them a second time. I doubt anyone will, but you can if you want anyway. But I will move just a little, for time's sake, a little bit quicker down through these. Now 4, let me change the markers. I should have done that from the get-go. Maybe it'll show up a little bit better in contrast. I'll do a black one. Okay, 12x cubed. Oh, wait a minute. Minus 26x squared plus 10x. We haven't been doing this, but the first thing you really need to do is ask yourself, is there anything that all three of these numbers or terms have in common? And in this case, yes, they're all even numbers. Hope I don't pull that off the wall. They're all even numbers, so what do you know would come out of each one of those three? That would be the number 2, okay? And also, because they're all even, but also they each possess what after the number? A variable. And so the greatest common factor already, you can tell in all three of those, is a 2, and as well an x to the first power. And so what I'm going to do now is rewrite this equation with a 2x factored out, because this is only going to work properly if I have it in the correct form. So what is 12x cubed divided by 2x? Well, 12 divided by 2 is 6. X cubed divided by x to the first power, in other words, 3 minus 1 in variables, is going to get me an x squared. Now I'm getting to the form that I want, see? Negative 26 divided by 2. Negative 26 divided by 2, that's negative 13. Don't forget though, your x squared divided by your x is just a single x. Exponent wise, 2 minus 1 gives you 1. Okay, and then what is 10 divided by 2? 10 divided by 2 is a positive 5, correct? And then x divided by x is x to the 0 power, which is 1. So we shut things off right there. Okay, now we're ready. So this one even added a step to the step that we were doing before. That's the only one up here like this, but keep an eye out for that sort of thing. Every now and then, one will be tossed in on you. Okay, so what are two factors of these numbers, end and beginning, multiplied together? 5 times 6 is 30. So what are two factors of 30 that when you add them together give you a negative 13? So what do you guys think? Is there anything that is coming to mind? Well, first of all, it's a positive number, but it's such a large negative that when added together, that's a strong hint that likely these are two negative numbers. They're going to have to be two negative numbers multiplied together to make a positive, but when added together, that are going to form such a large negative number. And so what are two factors of 30 that when added together would give you positive 30, would give you negative 13? Can't be 6 and 5, or negative 6 and negative 5, because when those would be added together, that would be negative 11, and that's not large enough. How about this? If I had the numbers negative 10 multiplied by negative 3, negative 10 times negative 3 is a positive what? 30. But when you combine or you add together negative 10 and negative 3, which is the same thing as negative 10 minus 3, what does that give you? Negative 13. Boom! We did it, guys. Good job. And so now what I'm going to do, just like I've been doing, I'm going to rewrite, but this one's tricky because I have to continue to bring down that 2x that I factored out all the way out from the beginning. But I'm going to bring down still, in my standard form, okay, I'm going to bring down my first term, 2x squared, and I'm going to plug in for that negative 13x. I'm going to do 2 terms instead of 1, but when you add them together, they're going to equal that. And so I'm going to have a negative 3x, okay? And then I'm going to have a minus 10x, got to use that other one, and then I'm going to bring down my final term, plus 5. And now, all that I'm going to do is I'm going to break these binomials up into their own parentheses, these binomials up into their own parentheses. Keep moving down that 2x though, it's the only way to have the correct answer when you're factoring. So I'm going to have in parentheses 6x squared, bring down my minus 3x, close that parentheses. I'm going to say plus, to make it technically correct, a negative 10 plus 5. Okay, and now what I'm going to do is erase what I put up here so I have plenty of space so I can go up here and work and not get into my next problem. These aren't going to be as bad, don't worry. Okay, so this one I have 2x, open parentheses, dot, 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 plus what's in another parentheses. I'm going to, what I'm going to do is I'm going to have my 2x. What can I bring though, guys? What can I bring? What can I bring? Because that has to be multiplied to it all. What can I bring out of a 6x squared minus 3x? Number-wise, what's in common right here? A 3. Okay, a 3 is in common. A 3 is in common. But what else? Keep trying to get ahead of myself. What else do I have in common as far as a variable? I have an x in common. A 3x. Okay, now I'm going to open my parentheses. And I'm going to divide 6x squared by 3x. What's 6 divided by 3? 6 divided by 3 is 2. What is x squared divided by x? Just a single x. Okay? Now, what is a 3x, or I'm sorry, a negative 3x divided by 3x? Negative 3 divided by 3 is negative 1, okay? X divided by x is just 1, which we don't really even express it. But negative 3x divided by 3x is just negative 1, okay? Close parentheses. Plus, I know I'm getting crammed up here, and it's one of those things, I have confined space, sorry about that, but it is what it is. Okay, plus negative 10x plus 5. What's in common in negative 10x and a positive 5? What I have in common is no variable, but what I have in common is a number, and that number is a 5. Now remember what I told you, if there's a negative number that starts the parentheses, do a negative, okay, as far as pulling out a factor. Just make sure you do that because it's necessary for the system to work. So I'm going to factor not a 5, but a negative 5 out of these two numbers because the first term in the parentheses is a negative. So I'm going to pull out a negative 5 from negative 10x. What's negative 10x divided by negative 5? Negative 10 divided by negative 5 is 2. I can't do anything with that x, and so that's going to remain. Alright, that's going to remain. 2x. What is 5 divided by negative 5? 5 divided by negative 5 is negative 1. And guys, I know this is a big, long, hard problem, but look at what I have in my parentheses. That tells me I'm on the right track. How do I write this in final form factored? I would do it this way. 2x, open parentheses, only use one of what's duplicated in those parentheses, 2x minus 1, okay? And then times what's found outside of the parentheses but inside, 3x minus 5. So my factored form is 2x, open parentheses, 2x minus 1, close parentheses, open parentheses, 3x minus 5. Now, stay with me. I know that was a tough one, and I actually expect probably for there to be some lostness, even though we were doing really well on this. And whoa, wait a minute. Well, stay with me. Let's finish up strongly, and it is going to continue to come together as we continue to work. You're not going to become a master of this overnight, but the more you work on it, you will do excellent. Every one of you, I have no doubt, you're such sharp kids. Brilliant minds. Okay, let's do this one now. 2x squared plus 3xy minus 14y squared. Now this one's different. Remember, we threw one of these in yesterday. Same thing right here, in that we have two variables at work. So how do we do that? Well, we still just use the numbers like we have been doing. What are two factors of negative 4 times 2, which is negative 28? What are two factors of negative 28 that when added together give you a positive 3? That's a significant number here. Two factors of negative 28 when added together give you a positive 3. How about 7 and 3? And one of them has to be negative because you have a negative product. However, since you have a positive number in the middle, the larger number has to be the positive. So 7 and 4, one has to be negative, but the positive has to be the larger of those two numbers. And that means you're going to have a positive 7 and you're going to have a negative 4, because 7 minus 4 equals, guess what? Our key number that we find in the middle, monkey in the middle, positive 3. Now that I know that, I'm going to rewrite this equation. The way I do that is use my first term, just bring it down, 2x squared, okay? And with that, I'm going to put a negative 4, and I attach the variables that are found in the middle. Here is the one that can throw you off. There are two variables in the middle, and not just one. It's not a single x, but it's a single x and being multiplied by a single y. And then I'm going to write the second term as a positive 7, both terms, okay, attached, because when added together, they equal what you find above right here. It's an easy way of remembering it. And then I bring down my last term, minus 14y squared. What I'm going to do from that point, guys, pretty simple. I'm just going to break a couple of binomials into parentheses, and they're still being added together, so mathematically that's okay. We're still sound. What do I have in common between these two terms? Number-wise, I have, between a 2 and a negative 4, I have a 2 in common. Variable-wise, I have a y there but no y there. I have a 2 x's, or x squared really is the way of saying it, and a single x, or to the first power there. And so my greatest common factor is a 2 in the numbers and a single x in the variables. Now I'm going to pull out a 2x from each one of those terms. What is 2x squared divided by 2x? It is only a single 1, which we don't write, x. And we also don't write to the first power, but we understand it. I divide negative 4xy by 2x. Negative 4 divided by 2 is minus 2, okay? And the x's are going to make something that's insignificant we don't write. Can't do anything with the y, all right? Plus, what's common in these two terms? Number-wise, a 7 and a negative 14, 7 will go into each of those, okay? X's, not in common. Y's, yes. There's at least a y to the first power in each one. And so I'm going to divide 7xy by 7y. Well, 7 divided by 7 is 1. I'm not going to write that. I can do nothing with the x, and so I just bring that down. Y divided by y is something insignificant that I don't write. Negative 14y squared divided by 7y. Negative 14 divided by 7 is negative 2. And y squared divided by y, subtract those exponents, 2 minus 1 is y. Aha! Did it right, didn't I? Didn't you? Very good. And so I only take one of these, x minus 2y. Okay, and so I don't have room, I'll write it below instead of side by side. And then what's outside, left outside of the parentheses, 2x plus 7y, I put inside a parentheses. Speedily, let's let's finish up the last one. Notice my numbers are the same, but I'm back to my normal form. Oh, thank you. I don't have any double variable. That makes it a lot easier, doesn't it? We already know 2 times negative 14 from up here is negative 28. And we also already know 2 factors of negative 28 that when added together equal a positive 3. And those 2 numbers are 7 and negative 4. So I'm just going to rewrite my first term, 2x squared, okay? And instead of plus 3x, I'm going to plug in with an x each one of these terms. And I'm going to write minus 4x, attach the variable, and not 2. Thank you, Lord. There's only 1 right here. And then I'm going to write my second one, plus 7x, when added together, give you what's found above. And then bring down my last term, minus 14. I'm going to break these 4 terms into parentheses separated by an addition sign. I'm going to break them into 2 parentheses. And what's common in 2x squared and minus 4x, we've already found up here, 2x is in common, okay? And 2x squared divided by 2x, we've already found is x. And negative 4x divided by 2x, instead of minus 2y, because we have no y's, it's just going to be minus 2. Negative 4 divided by 2 is negative 2. X divided by x is something insignificant we don't express, so just negative 2. Plus, what's common in 7x and negative 14? No variable, but the number 7 is. So I'm going to pull that out of there, meaning I'm going to divide 7x by 7. 7 divided by 7 is 1, which leaves me only with an x, technically 1x, but we don't write the 1. And negative 14 divided by 7 is negative 2. Looky there, guys. We're in good shape, aren't we? And I'm only going to use one of those, x minus 2's in parentheses, though. Drop the addition sign, and I'm going to put in the other parentheses what's left over outside the parentheses, which is 2x plus 7. All right, and that is that. I know that's a lot of work. I know your brain might be fried. This has been a pretty lengthy math lesson. Hopefully we haven't run over time-wise. But make sure you have good notes on this, because practicing this is going to help you understand it. Obviously, it's going to help you do well on your homework. And when you do well on your homework, because you understand it, you're going to do well on the test. But also, when you have these glorious notes, remember, because of our extraordinary circumstances, you also get to use all of your notes on your test. So make sure that you're taking good notes of this. Don't give up, guys. Keep your nose to the grindstone, and I say that completely knowing full well that you will, and you're going to succeed. And if not already, you are really going to enjoy factoring. There's a lot of fun to it. Thanks, guys.